Hello, guys, and welcome to another workshop in the Cybersecurity Workshop Series, a Cybertruck edition. And today we're going to be talking about Wireshark and discussing Wireshark Basics. And this slide deck is by me, Armand Kapoor, and let's get started. So, some requirements for this workshop, interactive workshop, will be the actual Wireshark program. It's free. You can run it on Linux, you can run it on Windows, and you can run it on Mac OS. And you also need a healthy mind. The reason I asked for this is because there's lots of data that's given to you in the UI of Wireshark, and if you, and it can get very overwhelming. So in order to actually use it to the best of its potential, you should have a healthy mind when going into it. Also, an open mind, into because you have to look at very specific um, UI elements. Just a quick disclaimer: this video may or may not contain tools and techniques used by hackers to penetrate and infect computer systems, servers, and personal mobile devices. The purpose of these videos is to demonstrate how these attacks will work so that you can protect yourself against them. And it's also to raise awareness of important cybersecurity issues in today's world. Techniques and tools learned from this video should only be performed on systems that you have explicit permission to do so. UC Merced, Q Project, Tech Equation Inc., nor me or all of my affiliates are not responsible for any malicious use of this information. So I'm going to go over just how the internet works, just some basics that you should know. So these slides are from a previous workshop, but I'm going to go over them again. So basically, you're sitting at home. You're known as the client, and so you send some sort of request for a website such as Google.com. So it gets sent to the internet, and then the internet basically sends your request to the server, which is google.com. It responds with the web page of google.com, and you get it back at home. That's basically how the internet works. All right. Internet basically connects you between a client and a server. And so there's sometimes in the client side, you can also, instead of going all the way to google.com asking for the web page, it looks for the cache to see if anything, if the web page is there, so you don't have to keep going to Google. Otherwise, if it's changed, then you should go, or you have to go to get the new data. um, there's also a protocol called DNS. Basically, computers are dumb and they don't know where google.com server is. So they have to find the actual IP address of that server. We'll be going into IP addresses later in this workshop. And what DNS does is basically it goes to a name server and says, okay, I have this address I want to go to, which is google.com. And give me the IP address for the google.com server where I can get the um, HTTP response, the web page from google.com. And that's how it works. And once you make a GET request, there are multiple different items that are shown that on your client side. And so each of them are basic GET requests that you send to the server, and google.com or the Google server returns all those multiple different items. Some examples of how the actual Wi-Fi packet is sent. Basically, there's packets of uh, that hold the GET request as well as like responses and all the other data, and this is how it's formed. So there's different layers. The top layer is HTTP. That's like you're making the request, and then the bottom one it keeps going all the way down, all the way to the physical medium. Basically, whether you're doing it wirelessly or via a Ethernet cord. This is another example of how it's formulated. So TCP is part of the transport layer, and IP is part of the IP layer, and then you got Ethernet part of the transport layer. We'll go into, if you don't understand what I'm talking about, that's fine. I will go more into it later. So there's multiple protocols per layer, and so you have to choose one basically for each layer, and then you formulate some sort of packet here. So we have Ethernet, IP, TCP, and HTTP. So this is one packet, data packet that you're sending over, and how these are passed down is first you have the data, which is basically your request or response, such as for the HTTP, and they have headers. Each layer has a header, which basically tells you what protocol is it. Like for example, if you look on the right here, either SMTP or HTTP or DNS. So it basically tells you which protocol and any other attributes of that same protocol. Now I'm going to be discussing the actual packet structure. So in Wi-Fi, so you have your HTTP, and then it gets wrapped into the TCP, and then IP, and then 802.11, which is basically Wi-Fi. So this is an example on how the packet is stored. So when you, you build the entire packet right here, you send it off to a wire or basically to the server. The server unwraps that packet to get the actual data that's stored in the HTTP layer, and then it says, "Oh, this client is requesting index.html or um, avatar.jpg," and then Google.com looks in its server and says, "Okay, here's the thing. Okay, I'll put it in the HTTP object, response object, have onion it with the TCP layer." Or encapsulated with a TCP layer, encapsulated with the IP layer, and then 802.11 Wi-Fi, and then send it back to the client through the internet, and then the client, it's basically vice versa in the client side. And so an example of a Wi-Fi packet is this. So you got the good stuff, good stuff on the bottom. Basically, the meat, the data, actual data, and then you got the HTTP header, and then you got the TCP header, IP header, and then the Ethernet header. So some terms that are used, commonly used, is that these headers are all referred to as mice, and the big data that's stored right here is known as the elephant. This is because just to compare the size of the data versus the headers, the header information is pretty small compared to a regular size payload that's stored in the data of the packet. So some important concepts. What is an IP address? So IP stands for Internet Protocol. It's the tiny waist of the entire uh, networking stack. It basically helps you communicate from server to client computer devices, which are connected to internet. So each device gets an IP address, and so that's how devices talk to each other, is through the IP addresses. It's basically a name for the IP addresses. There's also a public versus private IP. So basically, you sit behind a router in your home, and you have specific IP addresses, and then your router has its own IP address in which it talks to the internet. So your request will go from here to the router. Router takes out the IP header and puts its own, and then saves your IP address here, so that when it gets the response back from the internet, it knows that this response goes to this laptop here because that's what you requested. Um, if I'm going too fast, let me know. Does everyone understand so far? Yes? Okay, cool.
I'm
So,
good on my part, but I also took the class or same class as you, so yeah. Just speak up if you have questions about what he's going over.
TCP. Okay, so this is a very important concept which we'll be um, demoing in Wireshark. So, TCP is basically reliable communication in some sorts, where you send the data and the server says, "Okay, I you send an ACK packet back," which is basically an acknowledgement that you've sent, that the server received that packet, and this happens vice versa. But in order to set up this specific sort of connection, TCP connection, there are three steps that um, are involved. Don't worry about the sequence numbers. So the client, let's say the client wants to connect to a server. So what it does is sends a SYN packet. The server sends a SYN back with the acknowledgement saying that this is a SYN ACK packet. And then the client sends an acknowledgement to the server saying that, okay, I received your SYN ACK packet. Okay, now you can establish TCP. So in TCP, basically, one side sends data and the other side sends a acknowledgement saying that I got that data. So let's say, for example, in rare cases where one side would send data and then that packet would get dropped and the server doesn't hear anything. And so after a certain amount of time, this client or this device that sent the data and didn't receive an ACK would send it again. And then the server would receive it and then it would send an ACK and this device says, oh, okay, the server or this other device received my packet, so I can move on. And what's good about this is that you can break up the entire, like sometimes you want to send like a lot of information to the server or vice versa, and sometimes you have to break it up. And so that's why TCP is good for that, because you can use a sequence number to know what frames, fragmented data frames that you sent in different packets, so you can move them or you can reconstruct them on the other end. Now this is my works cited, and now we're going to get into the Wireshark tutorial. If you guys have any questions, now would be the time. Okay. Share my screen. Um, oh, you know what? I'll just share my entire browser desktop. So you guys can see this, right? Yes, no?
Yeah, I can see it.
Okay. So this here's some examples. Let me just go over the quick overview of Wireshark. So Wireshark um, basically analyzes all of the packets that are being sent in one specific interface. For example, my MacBook here is connected via Wi-Fi, and this is where all the packets are going. Um, this is like the amount of packets that are being sent per second. We have some activity on the loopback. Loopback is usually sent for stuff like, um, okay, request myself for this type of data or something like that. The reason my loopback is pretty high is because I installed a Pi-hole, which tells me that, which basically blocks ad by basically turning the DNS reply or sending a DNS reply for like ads to 0.0.0.0 four zeros, and that basically sends a request back to me. And so that's basically all the requests that I'm making that have any sort of privacy impeding or ads that I've been making. Also, other stuff as well. Um, there's different interfaces here, but what we're going to do is look at the Wi-Fi one.
I'll tell you, if you all know about Pi-hole, we have videos on YouTube about it, showing you how to install it.
Yes. So this is what's going on right now. You can see the packet number and when we started. It's going pretty fast. Does anyone know why I'm like sending thousands of packets per second per couple seconds? Can anyone guess why that's
Because of
happening
your
right now?
Zoom video.
Yes, because of my Zoom video. So these are all UDP. different. Or TCP is for sending like data packets that you really want to get sent that and reconstructing on the other end. UDP is for like video communication. Like for example, if I break out for like zero point 0.1 second, you lose that packet, it's fine. So UDP is um, a bit more unreliable in terms of data communication, but it's perfect for fast, just get to the point sort of communication. Um, so let me stop a little bit. Or basically, you have all this data that's coming in. What you can do, let me, okay. Now, up here, you can basically make a filter saying that I only want to filter TCP connections. See, these are all the TCP connections, application data, all this stuff. Um, that's the protocol right here. Now let me see if I can. Okay, I'm gonna keep this side because I'll be making HTTP requests. So let's make an HTTP request. Let's let me curl. Let's do google.com. Okay. See, we got HTTP there. So if you want to filter by HTTP for the protocol, what do we type here on the top? If you want HTTP packets, what do we put up here? If if this
Just HTTP.
HTTP, yes, we search up HTTP. This is it. So what we got, we have a GET request, which we made here with Google.com. And so you can see the frame headers. You got um, all different types of attributes, which is basically the Wi-Fi frame from my computer to my router. I got Ethernet here. I got IP. My IP address is 10.0.0.18. That's my local IP address. And a destination. This is Google's IP server. This is Google's server. Um, Now we got transmission control protocol. That's TCP. There's different ports. You don't need to know basically all of this, but basically, you got all the headers right here, and then you got the actual data. You got the host Google.com. You got the user agent, which is curl basically. You got accept this that. So if you were to make this request in a browser, this is basically what you would get. You would when you open the Chrome DevTools, you get HTTP. You basically see these two right here. You also see accept here, and then you see the user agent as Google as Chrome if you're using Chrome, and you can see it records the response in this frame right here. So if you look in this frame, if you double click on it, it'll automatically go to that frame. Let me cancel this out. I stopped my recording of this. All you do is with this, and then you can start a new capture filter with that. Um, what you have here, you have basically the um, destination or the response. So you can see in the Internet Protocol, the source was Google's um, server, and the destination was my personal computer. And here you can see the TCP data. And if you see all this data right here, you can see it basically matches this right here. This is basically the AXI version, the human readable format of the corresponding hex digits here. For example, you can see content type. No, that's the HTTP header. Um, Google.com right here, href. That that's right here. Right here. That's the data that's being sent right here. So if you want to avoid, see, if I had this Wireshark in like on my router or something, I would be able to see every single website you saw and every single um, response, and I would be able to decode it, everything, all that, without even being on your computer. This is known as a man in the middle attack. Does anyone know, other than Solomon, um, how this is avoided in real life? Or typically, how is this avoided?
I guess it'd be rerouting it or using like a VPN or something like that sort.
It's so that means that everyone has to have a VPN in order to be um, secure. Because I could, if I'm sitting in the middle and I get a get request from Google.com from one device, all I have to do is say, okay, this is the response, and there's no checking that. I can easily change the source address, saying, oh, this is from Google.com. Don't worry, and I'll just send it off.
Oh, I mean, are you more so alluding to like the cross origin, like making sure that the server and the destination are like the request destination are the same?
It's more so, um, not not exactly. It's more so in the protocol or in the Wi-Fi packet itself. There's a thing that you everyone should be aware of. Um, if you type in HTTP, okay, let me start. Uh, Continue without saving. Oh, now it's a current filter is HTTP. So let me make a Google.com request, right? Oops. So base. Okay, no, never mind. That's working. So this is Google.com, right? So you didn't see that. Okay, Google.com was moved here or something. So this was a different website. Um, so if you look in the header right here, what do you see that's not HTTP?
I mean, the dub.
No, no, no. What's what makes this not HTTP? HTTP request ish, sort of. The HTTPS. S stands for
Oh,
secure. So basically, what it does is it takes everything you have, including like all the TCP data from at the TCP layer, and adds an extra one called TLS. Does anyone know what TLS stands for? Solomon?
I think isn't it transport layer security?
Yeah, transport layer security.
I thought
So
I remembered it.
let's so it's right here. TLS. TLS right here. That's transport layer security. It's often combined with TCP, but it can be combined with pretty much anything, even UDP, I believe so. Now let me cancel this. Um, Wireshark has, if you go to wireshark.com.org, they have lots of sample captures, which we're going to be looking at. So let me open Wireshark again. They have a simple HTTP cap. So you have this protocol, TCP, HTTP. Now, what I'm going to teach you is some filters. Um, is HTTP. That's how you got the HTTP stuff. You got GET requests and then you got the responses. If you click on here, you got the full response in frame 38. This is 38, and that's your response right here. Let's say you want to filter dot response or request dot equals get. Like you want to filter for a get request. See, you got get request here. We don't have post requests here, but let's do that. Oh, I guess we don't have any post requests. What else you can do? You can do response code 200. Um, 200 is basically an okay. These are the responses that were made based on the HTTP. So, for example, if you made two HTTP GET requests and both of them return 200 okay. 200 is the response code. So, what you want to do? Response code equals 200, and that's it. You can search for 302. 302 is for redirects. There's other filters you can do. Those are the main ones. You can search for a TCP. What I told you during the slide deck is that sometimes the frame or the data is too big to be fit into one data packet, so it's fragmented. So, for example, I sent this TCP or this GET request. No, sorry, where's the GET request? Right here. And the source was 145 point whatever. The destination was 216, and so it started sending me request TCP data. Let's see, from 216. It seems from here, starting from here, sequence equals 1. What you can do is follow TCP stream, basically all those fragmented data. And you click on that, you see all the data that was right here. This entire, all these packets were of this TCP stream for that specific GET request. And this is what you got. You got all this right here. You got this. You got this. This is like the TCP. This is data encoded. I'm sure you can unencode it or decode it. That's the refer. You got all these HTTP headers and stuff. And that's it. You got all that cool stuff from Wireshark. You can basically do anything you want. You can capture a lot of stuff. If you want to take out the filter, all you have to do is hit enter, clear, and hit enter. Look, there's also a DNS request. Let's search for a DNS. You have to do it lowercase. These are DNS requests. You got the standard query, and you got the query response. So with the Pi-hole, the response will not come from the server, but it'll come from my Pi-hole. So this was the query that I made, and I made this query, page add to the Google syndication.com. This basically is a Google thing. And then there's DNS response is right here. And I got the answers right here. I got the CNAME. These are all like basic DNS stuff. Don't worry about that. You got, well, basically what this is that this is inside this CNAME, all that. And what's most important is that you got the IP addresses right here. It's known as adder 216, 239, 59, 104. These are the IP addresses of whatever query you made here. Also, another thing before I let you guys go would be you can search by IP adder. You can do IP adder, like whatever address, let's say 145, anything that involves 140, the communication of 145, 254, 160, and 237. Oh, did I do? Okay. Oops. Oh, I think I spelled that wrong. Oh, I made some. Oh, 245. 145, 250. Oh, it's 160. So anything involves a communication from this address, either it's in the source or destination, the bam, filter. Also, another quick filter, you can do IP source. IP.source. So IP is the header, and then source is the attribute of the IP header. So if you click on this, you can see all the sources right here and wherever it's been talking to. And so
I'm curious if you can filter by regular expression. So like the way that you were filtering by like 1.160 or like any specific thing, can you use a regex to filter quicker?
I'm not familiar with regex, but I'm sure you can do something like that. Why don't you let us know when you find out? So that was basically the end of my workshop. If no one has any questions, I'm going to end the recording. Thank you, and please like and subscribe to our YouTube channel, and I'll see you guys next time.